My name is Simonetta Ercoli. I represent the StarLight Handy Planetarium Association. Our slogan is "The most incomprehensible thing about the universe is that it is comprehensible" by Albert Einstein. And our goal is discovering the incomprehensible from a tiny handy planetarium to the immense universe around us. This is our planetarium, a paper model in different sizes, held between the fingers and guided by a special worksheet. It allows students to learn about the structure and the dynamics of the celestial sphere on their own. We carry out educational activities at the schools and disseminate them in different historical places of the city or in the surroundings. For school, we run a workshop called Star Hunting, where we help students recognize the constellation of our northern hemisphere through various activities. Having met a partially sighted student in a class, we developed a parallel path for him to follow the laboratory with his classmates. We prepared worksheets with pins inserted to represent the stars of the main circumpolar constellations. As we had him touch the pins, we would explain what the stars were and the meanings of the constellation. Then we had him join the pins with a thread to make the constellation shapes. At the end, we had him compare his design with the one we had made showing the traditional outline. Then we guided him in recognizing the same constellation on a simplified star chart with engraved stars of different sizes joined by slightly raised lines. Finally, we helped him to recognize the circumpolar nature of the stars around the North Star by rotating the map. Another activity we did with blind people was carried out on the occasion of the total solar eclipse of August 21, 2017 during a live stream of the event. After an introduction of the difference between the three bodies involved, we had the participant manipulate a card with a representation of the lunar phases made with different materials to give the perception of the temperature difference between the illuminated and the shaded part of the moon. All the lunar phases had the caption in Braille. Then we used the NASA publication Get a Feel for Eclipse, made to involve blind people in the event. One page highlighted the celestial mechanics of the eclipse and different phases with a caption in Braille. Another page showed the path of the eclipse through the US, and it was on this that we helped the participants to follow the progress of the eclipse during the live stream. We also do different kinds of projects, like the Harmonies of the Planets. It is a research that aims at creating musical composition devoted to each planet of our solar system, following the path of Johannes Kepler in his Harmonies Mundi treatise. Music study has played an important role since ancient times. The first to try to discover the relationships between the musical intervals and to talk about harmony was the Greek philosopher Pythagoras. He considered the universe proportional and ordered, at the basis of which was the number. Music and geometry are the concrete expression of its ordered form. The interval is the distance between two sounds, produced consecutively or between two products simultaneously. The main ranges are the octava, the fifth, the fourth, tone, and semitone. The Pythagorean model remained for a long time a point of reference for cosmology, so much so that Kepler also referred to the Pythagorean the Platonic idea of the universe when he undertook his work to confirm if the scheme of the universe and its parts could be expressed in numerical and geometric relationships. His search for the explanation of the motion of the solar system planets started from the heliocentric model of the Copernican system, with the analysis of some inconsistencies present, such as the permanence of the epicycles, which did not offer a correct answer to the anomalous path of the planets around the Sun. Kepler represented on a rope the mathematical ratios calculated for the intervals, and showed that they were consonants both with respect to the whole string and to each other. Then he sought all the consonants of a monochord even on a circle, the basic figure of the perfection of the universe, thanks to the division of the closed line by description of regular polygons, and with them beat the harmonic relations between the planets. Through the diameter, the triangles, the square, the pentagon, the hexagon, and the octagon. Comparing the arc subtended by one of the sides with the remaining arcs, he obtained the exact octave ratio corresponding to the first harmonic consonances of octava, fifth, fourth, and third measure. The reference circle was for him the zodiac, against which the calculation of the conjunction of the planet were made, and therefore it was possible to highlight the correlation between the regular polygons inscribed in a circumference and the distances of the planets from the Sun. But this path was not satisfactory, since the inscription and circumscription model of regular polygons could be carried out indefinitely, while there were only 6 known planets. Moreover, it was not consistent to insert flat figures between the solids represented by the spheres in which the planets were thought to be embedded. For this reason, he moved his attention to the position of the regular polyhedrons between the orbits of the planets. The Earth was placed as a divider between the stable solid, cube, tetrahedron, dodecahedron, external to its orbit, and the unstable ones, octahedron, icosahedron, internal to it. In this reorganization, the ratio between the rays of the two spheres which refer to each polyhedron was well defined and characteristic. For example, the tetrahedron corresponded to the larger ratio perfectly at 1 to 3. This hypothesis gave a justification both to the number of the orbits of the planets and to their distance from the center of the planetary system. Thus the theory account for the observations? Unfortunately no. The observation made by Tycho Brahe suggested not perfectly central distances of each planet toward the Sun. Thus, he abandoned the painstakingly constructed model, but did not give up geometry. So he moved his attention on the definition of the another kind of shapes for orbits traveled by the planets, and trying to show that the causes of eccentricities and the periods of the orbits of the planets corresponded to harmonious proportion, he arrived at a reformulation of his three laws. Using the values found in the most static moment, that is, those of aphelion and perihelion, he calculated the amplitude of the daily orbital arcs traveled by each planet to evaluate whether they produced musical intervals. The found values did not match perfectly, but the differences were so small that they were irrelevant at the observations. This observation led him to shift his attention to the amplitudes of the orbital arcs traveled by two adjacent planets, to evaluate whether they produce musical intervals. So, he calculated the convergent extern motion, those that are in the apses closest to each other, perihelion of the superior planet and aphelion of the inferior, and those divergent, that is, those that are opposite to the apses, aphelion of the superior planet and perihelion of the inferior. From this he derived the relationship that linked the axis of the ellipse and the orbital periods, and came to the formulation of the so-called harmonic law, published in 1619 in Harmonices Mundi, Book 5, Chapter 3, where he wrote, "It's very certain that the proportion that binds the periodic time of each pair of planets is precisely the proportion sesquialtera of the average distances. The sesquialtera proportion consists of the 3-to-2 ratios, which is exactly equivalent to the perfect fifth interval that governs the entire Pythagorean music system." Each pair of adjacent planets in the path of their orbits generate a different melody in their divergence and convergence. Kepler was ready to write its pentagram. From this interval, Khalid Shomali composed a song expanded in an aesthetic way for each planet and for each convergence between the planets. A concert was performed with a background video in flat screen, which summarized the main stage of our work.